What's up, everybody? Welcome back. So I wanted to talk today about the hype that the Tesla's been having this last 2 weeks, and I just wanted to pretty much share with you a thought and something that I think people technically people are not talking about it, and people are investing in Tesla just because a lot of people are investing on it. But today I want to talk about going back to the September 22nd of 2020 event of the battery day for Tesla, and I want to use this pitch and a couple more things to go into a little bit of a detail on the 4680 battery that Elon Musk announced this day. And I also want to make sure that we compare it to the other ones, and I have some notes for that, just to quickly go over them and get our feet dirty on it and understand the batteries, right? So I'm just gonna jump into this, and because most of this is boring and it's hey, this is what we're trying to do, but I'm just gonna jump into this. I want to talk about the cell design. I don't care about the rest, maybe a little bit of these, but we're gonna focus on cell design. And I think this is what's important on the 4680 design. The 4680 design has essentially 46 millimeters by 80 millimeters, and that's why they call it like that. That's essentially it. So going into it, this is essentially the conventional design. The conventional design of the battery, and we're gonna go back to those notes that I was referring to a minute ago. So the conventional design of a battery, it just pretty much starts with this two right here. So these two right here are essentially the ones that we have right now. Tesla has this on some of their cars, but the old ones were the 1865. 2170s are the ones that you see on the Model 3s, the Model Ys, the Model S's, and that's pretty much it. But the 4680, again, 2170 is a 21 by 70 millimeters, a 4680 is a 46 by 80 millimeters. Essentially, what they're doing with this is they're saying, okay, and I want to go back to this right here, but let's go in order, right? So a regular design battery has a cap and a can, and it has, obviously, your positive and your negative side, and essentially speaking, all the heat radiates radially outwards. So the heat radiates radially outwards. So the heat transfer is going to be outside, not axially, because of this design, right? So this is essentially it. This is the old stuff. This is what we all know. This is what we see on the roads. However, for the new designs, what they've done is they say, okay, hey, how can I find a way that I can optimize my cooling, my heat transfer rates of extraction of heat? And how can I make a system that around it can actually cool the batteries better? Because, hey, if I can manage energy better, then I can actually charge batteries faster. And that's just basic thermodynamics, Q in, Q out. However you extract the heat, the faster you can actually go back to the steady state operation. So what they designed was they come up with this tap idea and this jelly roll. And essentially speaking is, what I'm going to go back to this is, we have, it's like a sandwich, right? So you have the separator, okay, which is in between the anode and the cathode. The cathode, it's essentially a lithium ion sheet, and the anode is just a copper sheet. And that's what you see on the pictures when you see it. They roll this thing and they add some tabs, right? They add some tabs and then they put them in there. The idea with this design is that you can extract heat axially, but not radially. So the heat comes out from the top and from the bottom. So when you wrap them around, the tabs, they all kind of collide together. They form what you've seen on these images, which is, this is what I was talking to you about. They rolled it. Here's a better image of what I was talking to you about. You get the separator, right? You get the cathode, you get the anode, and essentially speaking, you have your battery with tabs now. These are the tabs that they're including for the 4680 design. that will make this better battery, right? So here's the thing, right? So it's fully powered. You get this charge going on. You get the charging back on again, and it's essentially speaking. Here it is. Here's where I wanted to go. So old battery, 2017, 50%. They went larger. So remember, so it's 18 millimeters in diameter, 65 millimeters in height, 70 millimeters in height, 21 millimeters in diameter. That's essentially it. With the new cell, what they're trying to pretty much sure is, okay, we can reduce the cost and essentially have more range, because you get more energy per se. So if we go back to this, if we go back to the next one, what's the actual effect of the 4680 into power, energy, and range? Well, they say that they all go up, right? But I just wanted to say, that essentially, in my opinion, the best approach and the benefit of this battery is how you cool it. If you get the energy out, actually, you can come up with ways to cool it. Like, you don't really need to cool it outside like they've done before with some epoxy. And if you see the conventional ways that they build them, they have they pretty much come up with here, right? So this is the big ones. This is Sandy Munro. We're gonna go into this, but essentially you just get epoxy around it, and that just pretty much gives you the cooling around it, and then they just air cool it. So here's the tabs. This is essentially your separator goes in between, and then you get your cathode, your anode. It's like a sandwich in there, so you get fewer parts, simple to manufacture, and then the conductivity. Here's where I wanted to go: energy, range, and power. Note that they don't say energy density, and I think that's one of the things that I mean, it makes sense, right? You get a bigger battery, you can store more energy. And then essentially, you got 46 air. You can do the math, right? Like, bigger battery, 5 times that. Like I was telling you, that's the geometry of it. Interesting. There's no tabs. It's just like pretty much tabless. More power, more range. This all makes sense because it's a bigger battery. So we're done with that. So now I just wanted to go back to the benefits, right? So why are they? This is just my opinion, and this is why I think these batteries are good, and they're gonna change, and they're gonna be applied to semis and everything. The release of heat, okay, that you get from a 4680, if it's an axial, like top and bottom, you can actually come up with like a cold plate design that you can actually put all the batteries stacked up together, get them all close to each other, and then you can actually cool them that way. Right now they have epoxy in between, and I'm pretty sure you've seen those images from Sandy Munro when he took the Model 3 apart, that you get all that epoxy around it. It looks like a Panasonic battery, like a regular, AA battery. The cooling benefits, I think this is what's going to be the most important thing. If you generate less heat, you can definitely cool it better. And then essentially this is it: charge and discharge, prevent battery damages. If you can actually cool this battery, manage it thermally, this battery is going to be it's going to be great. So one of the things I want to show you, because I really like to see things in analysis, is this is the design that they're saying that they're going to have. This is the bottom of it. Maybe that's what they're calling it. And some of the things that Sandy Munro says and how they're going to work out. So note how obviously there's going to be an array of, how the positives and the negatives overlap. And he has this idea right here where you have the insulation, the collector, the insulation, and the other collector. That's pretty much the battery itself. How are we proponents of cooling this thing? So this is just a layout on how this battery might work. And I think this is pretty smart because all these batteries are connected to each other. You can spot weld all these things. You can fill the holes in between the batteries with epoxy just to give it more rigidity, like they've done before. But essentially speaking, this is it. This is how it should look. And they are, if you can see, they're connected in parallel groups. So here it is what I wanted to talk to you about it. You have a structural macro. Let me just do. Let's mark this up. So this right here, very important, right here. So you get a structural micro channel. That's the top plate. That's a plate to cool it. And then you also have the bottom one, right? Plate, right? And then you have some, you need to cool the top of the battery. This is the top, and that would be the bottom. And then essentially you connect them in a way where your cathode and the anode are connected through a flow path of the current. And then you have insulating epoxy and some insulating plates in between the actual plates. And then obviously you have your pack bottom structural casting. That would be like what they're saying is like, okay, it's going to give rigidity to the whole unit. But essentially speaking, this is how I think it's going to look like. They're going to be stacked, packed up. They are going to be cooled with plates. And I think that either you cool them, there will be a water cool system for plates, or it will be a system for just simply cooling them with air, but essentially speaking, just cooling plates. So going back to this analysis, which I think is pretty interesting. So this is CFD analysis that was done into 2 examples of the current design of battery packs that we have in the market. The one on the top, it's using cold plate cooling, which is essentially you have a cold plate that you cool, and then that extracts the heat into the whatever extraction from the radial outwards from each of the cylinders. On the bottom, you have immersion cooling, which is you really have cooling around the battery. So essentially speaking, and it's obvious, one of them is going to be more efficient than the other one, but the cooling, immersion cooling, it's not really efficient. This, in my opinion, is what we see on immersion cooling. This is essentially wrapping around and pretty much having everything into a dielectric fluid, which runs inlet from the right, it flows around it, and then it goes outlet, picks up all that heat. So the heat pickup, as you can see, it's around 40 degrees. Now, this is efficient, but the problem is when you have an old design of batteries that essentially, now you have bigger batteries, and when you compare the cooling systems of the old ones to this ones, if you have axial heat dissipation, then you're gonna have to change your cooling design. So in my opinion, this is gonna be done by cooling with cold plates, and it's going to be a more efficient way. If you can actually cool these batteries faster, you can charge them faster, and then you can definitely maintain the integrity of the battery in the long term, and then your battery is going to last longer, your car is going to have more range. So folks, that's all I wanted to cover today. Very simple understanding of the 4680s. Obviously we didn't go into a lot of detail on the construction of the battery or anything like that, but I just wanted you to understand how they work. I just want you to understand the main benefit, in my opinion, is this: fast charge and discharge. The energy density is there, and so I just wanted to touch. Some people they think that the real benefit of these batteries manufacturing cost, which will be lower, but in my opinion, it goes further than that. You have less batteries in the pack, but you get a cheaper product, more margins. But in my opinion, it goes further than that. If you check the Tesla patents on how they design this tabless geometry, if they are able to extract the heat from the top and the bottom, and you are able to cool it better with the actual the thermal management system, you will have a longer lasting battery that could run hotter and definitely give you more. You can have more energy density in per se. So if you can definitely generate, if you generate less heat, which in theory that might not be achievable, but if you can remove that heat faster, then that's what's going to give you the benefit. So folks, that's all I have. I hope you liked the video. It was quick. We're gonna make another video about the other automakers and see what they're doing in terms of battery technology, and see you later.